Examples of limits of accuracy, part 1. We've been looking at approximation and upper and lower bounds, and there might be questions in the exam around this. So here are some examples of exam questions that we can work through just to make sure that you understand what's going on. And don't think this is just for maths. We use approximation in everyday life. So, and I'm sure you can think of some examples yourself. So, let's start with this question. A bag of flour has a mass of 1,500 grams to the nearest 10 grams. Find the upper bound for the mass of 10 bags of flour. So here we have a bag of flour. It weighs 1,500 grams, or that's the weight we want it to be. The limit of accuracy is 10 grams. And if you can remember from the previous videos, the way that we find out the upper and lower bounds is to get this value and to divide it by 2. So in this case, it's 5 grams. So the upper bound for one bag is the ideal weight, 1,500 grams, plus half of the nearest value, which is 5. And when you add those two together, you get 1,505 grams. So this is the upper bound for one bag. But the question is asking us for 10 bags. So the upper bound for 10 bags is this same value here, 1,500 plus 5 bracket times 10 for the 10 bags. So we know this value equals 1,505. Now we have to multiply it by 10 and we get 15,050 grams. And this is a fairly large number, and grams is a fairly small unit, so we can put it into a larger unit. We know that 1,000 grams equals 1 kilogram. So here there are 3 zeros. So when we're converting, we need to move the decimal place 3 places, I mean. So here, the decimal point is here. So we move it 1, 2, 3. So that becomes 15.05 kilograms. Let's look at another example. So the first was about weight. This one is about height. It can be about any form of measurement. So in this example, Stephen is 1.8 meters tall, rounded to the nearest 10 centimeters. James is 1.63 meters tall, rounded to the nearest centimeter. So the thing to watch out for is that this is a 10 centimeter, this is 1 centimeter. So the question is, what is the smallest possible difference in their heights? So if you had two people of a different height, the way that you'd work out the smallest difference between them is to get the lower bound for Stephen minus the upper bound for James. So here, the lower bound for Stephen is 1.8, and we've got that from here, minus, and then the brackets is this value, 10 centimeters, divided by 2. Now, the thing to watch out for, and an easy trap you can get into, is where you're dealing with numbers with different units. So here we're dealing with meters, and here we're dealing with centimeters. So someone who sets exam questions, they like doing these things because it like trips you up a little bit. So you've got to be aware of it. So we need to convert 10 centimeters into meters. Now we know that 100 centimeters equals 1 meter. 10 centimeters equals 0.1 meter. Because what we've done is we've sort of moved the decimal place. So here, if we're multiplying this by 100, because 100 goes into meter, then it's 1, 2. So it becomes 0.1 meters. So here 0.1 meters divided by 2, so that equals 1.8 minus 0.05. 0.05 is half of 0.1. When you take these two away, when you take that away from 1.8, it gives you 1.75. The upper bound for James is his height, the 1.63, plus, because we're looking for the upper bound, 0.01 divided by 2. And so the question is, why is this 0.01, whereas here is 0.1? Well, here it was to the nearest 10 centimeters. Here it's to the nearest 1 centimeter. So where it says nearest centimeter, it means 1 centimeter. And 1 centimeter, when we're converting it into meters, is 0.01 meters. So, and we're going to halve that. So half of 0.01 is 0.005. So we have the height, the 1.63, plus the 0.005, which gives you 1.635 meters. So this is Stephen's lowest bound, and this is James's highest or upper bound. So all we need to do is to find the smallest distance, we need to take away Stephen's lowest bound from James's highest bound. When you do that, you get this value. And 0.115 meters is a respectable answer, but it's nice to put that, because it's a fairly low number, put it back into centimeters. So the way you put it back into centimeters is this conversion here. 100 centimeters is a meter. So this has to move 2 places, 1, 2, and that produces 11.5 centimeters. And a third example before you go on to having a go yourself. So this is a piece of A4 paper, and we can think about it just like so. And it has a width of 21.1 centimeters, and we get it from here, and it's got a length of 29.7 centimeters. And this question is asking you to do a number of things. What are the lower and upper bounds of its area in square centimeters? And also it wants you to correct it in approximation to 1 decimal place. So this involves a number of manipulations, but if you do it sequentially and logically, it's really quite easy. And don't forget that area is where you multiply one side by another, and then it gives you the area of the sheet of paper. So it's asking you what is the area of the sheet of paper when it's at its lowest and highest bounds. So it doesn't matter which way you do it. Let's start with the upper bound. So the upper bound is the width, 21.1 centimeters, plus, it's telling us here to the nearest 0.1 centimeter. So 0.1 centimeter divided by 2, and 0.1 centimeter divided by 2 is 0.05. So if we add 0.05 to the width, which is 21.1, we get a value of 21.15 centimeters. So that's the upper bound of the width. And we do exactly the same for the length. So the upper bound is 29.7, and then we use this calculation again, the 0.05, and if we add 0.05 to that, we get 29.75 centimeters. And in order to get the area, you just multiply these two together. So 21.15 centimetres multiplied by 29.75 gives you a value of 629.2125 centimetres. Now, watch out for this because although it's centimetres, when you multiply centimetres by centimetres, you get centimetres squared. And in fact, it mentions it up here, square centimetres. And what it's asking you to do it to one decimal place. So this is the decimal place here between the 2 and the 1. And because 1 is lower than 5, this value stays the same. So the answer is 629.2 centimetres. So that's the area for the upper bound. And don't forget to put in the square as well. Let's look at the lower bound. So we do exactly the same sort of thing here, except we take away the measurements, the bounds. So all of this remains the same, but we're taking it away. So it's 21.1, which is the width, as we've seen earlier. And it's not plus, but minus 0.05. And this gives a value of 21.05. The lower bound for the length, again, is exactly the same, but you take away that value and you get 29.65. So the next thing to do is to work out the area. And so the area is 21.05, which is this value, multiplied by 29.65, which is this value. And when you multiply them together, you get 624.1325. And don't forget centimetres squared. And again, the question is asking us to the correct one decimal place. So the one decimal place is here. 3 is lower than 5. So this value stays the same. And so the answer is 624.1 centimetres squared to one decimal place.